We're here at the Iscar booth at IMTS, and we're going to highlight some 3D printing technologies for the production of cutting tools this week. And here you can see here we've got some parting and grooving tools, some milling tools, and some turning tools. And the idea of just showing how the 3D printing, we can really do some unique things with creating coolant ports and channels that allow us to optimize the coolant flow, pressure, flow rates, pinpoint the coolant right to the cutting edge, which helps with tool life, usually 30, 40, 50% improvements, chip evacuation, reduce the amount of recutting of chips, and a lot of good benefits that can come out of the utilization, improving the utilization of the cutting tool by using the 3D printing technologies. So you can see here how we've optimized the coolant channels. Typically with traditional production methods, you might have one hole that's drilled in and it intersects at a 90-degree angle or at a shallow angle, but you can kind of see that we've got angled coolant ports, 2 of them on this insert, and then if we rotate it around, we got 3 more over here, angled to a perfect angle to direct right to the cutting edge and help evacuate the chips from the cutting zone. If you can zoom in on these, this is a slotting cutter example, and especially on this technology here, which is an interchangeable head, you can see how small those inserts are. They're tangentially mounted. So that's another benefit of the printing technologies, is being able to come up with, it really broadens the range of tools that we can offer. The small inserts, being able to press those and manufacture them, and then be able to put those in a cutter body that traditionally probably wouldn't be possible. Smaller diameter milling tools that are indexable, kind of replacing the solid carbide lines. I'd like to introduce Pat Klein. Pat's the National Product Manager for hole making products at Iscar USA, and he's going to talk to you a little bit about the drilling technologies that are being produced with 3D printing technologies.
Thanks, Tom. All right, good afternoon, and hope you're having a good IMTS. We're going to talk a little bit about our versatile Sumo Cam drilling line, and every time we try to come out with more versatility, make it more productive to fit into more customer applications. And so looking in the small miniature world, we're going to take, which is going to be the Pico line, fitting on Swiss machines and high productivity equipment. We've taken the Multi-Master, the Pico line, and we've added Sumo Cam to it to give more versatility to the Pico line, but also put this Sumo Cam drill in more applications. So what you see here is a 3xD Sumo Cam. It's our replaceable head solid carbide drill with through coolant. The coolant itself is done through computational fluid dynamic software. We 3D print the bodies to take advantage of that software so that we can optimize chip flow. We know that in drilling applications, one of the major factors in a successful drilling operation, and not only successful, but also reducing your cycle time by having high feed rates. We know a feed rate limitator is evacuating the chips. So by being able to optimize the chip evacuation due to the coolant flow, not only can we speed the process up, we can make it more stable, which translates into tool life. All of these things are possible due to the computational fluid dynamic software and the ability to additive manufacture or 3D print. So these go down to 4 millimeter in size. They're in 0.1 millimeter increments. We have 6 standard head geometries that fit on these. It goes from 4 millimeter up to 10 millimeter, so that's 157 up to 394 in 4/1000ths of an inch increments. 6 standard geometries, and this allows it to go directly on the block on a Swiss machine. It can be used in other applications too, but main target's that. And then moving up here, again, looking at the versatility of the Sumo Cam line, we've taken our Sumo Cam, these are 2xD, and what we've done is we put the multi-master shank connection on it. I don't know the exact number of multi-master combinations, but it's somewhere in the upper 50,000 range, and we've just added to that now of possible combinations. So if a customer is utilizing our screw-on threaded multi-master connections, either steel shanks, this is in a collet, so it can either be a collet or it could be a straight steel shank, or here's a solid carbide shank so that you can have longer extension ratios. Again, same size range, 4 millimeter up to 394. Same number of head geometries, 6 different standard head geometries, 0.1 millimeter increments. And again, these tools also take advantage of our computational fluid dynamics software along with additive manufacturing, so we can have those nice smooth coolant transitions instead of sharp angles. That way we can keep the pressure up as well as the flow rate, giving us maximum coolant to the cutting edge for chip evacuation. Also, I didn't speak about it before, but one of the things with good chip evacuation is good surface finish. So not only is it tool life and performance as far as how fast you can feed, it also improves the whole quality by having a better surface finish. And so these particular lines, the Multi-Master line and the Pico line of SumoChem, add to the versatility of the tool, and this gives you some more options. Then you don't have to utilize this. These are for small machining centers with the BT30 connection, like a Brothers or a Fanuc Robo drill. But you could use this on any connection that can hold a straight shank, such as any ER collet. Could be a normal CNC, normal size CNC mill or lathe, and you could utilize it with even the longer body. So if you had a real long extension that you needed to get past something, but a short drilling depth, very, very good solution to that, because being able to utilize the solid carbide gives you rigidity on that length to diameter ratio. Rigidity is going to translate into a performance improvement as far as the parameters you can run to reduce your cycle time. And we know that carbide likes rigidity. It's going to give you an improvement in tool life as well. So these are improvements we've made with the additive 3D manufacturing within the SumoChem family. Thank you.
So one last stop here at the Iscar booth. I want to introduce you to Robert Navarrete, and he's a turning specialist for Iscar USA, and he's going to talk to you about some turning technologies for Swiss that are produced with 3D printing technology.
So this is our Neo Swiss line, 3D printed technology. We're including through the tool coolant technology, computational fluid dynamics. So what we're doing is we're taking the ability of 3D printing and eliminating the old techniques of manufacturing, where it would be a straight fluid cut, drilling holes where we'd be coming into corners, the coolant would slow down. So now we're able to flow properly, where the coolant flow does not get disrupted. So what we're doing with the Neo Swiss, so it's a very rigid clamping system. A patent clamping system where we're able to connect the coolant ports to the bottom. Connect the coolant ports to the bottom, connecting this position, 4 points of contact, 7 to 8 Newton meters clamping pressure, coolant's going directly to the cutting edge. What that does for us is once these chips are being curled, the coolant pressure is actually helping the chips break. The coolant is helping the chips break, so we're actually not completely relying on the chip former. The coolant's helping us cool it down, chip curl, so we're getting better tool life. So with this system as well, we'll take one shank, and it's going to accommodate a range of cutting tools. We're going to be able to part off, turn, groove, and thread with the same exact head. One head's going to accommodate left and right hand tools as well. What we're also doing is we're able to have a right hand shank and accommodate Y-axis turning. So if we're having issues in the manufacturing process where we're not able to break a chip regardless of the techniques we're using, we use the rotational forces, gravity in our favor, to get that chip to curl and fall into the chip conveyor when we're not able to break chips. What we also have is a offline mechanism, so once these tools are running in the machine, we can pull one out, hit cycle start, hit run, and we're indexing offline as that tool's running in the machine. Minimal downtime. The repeatability with the Neo Swiss system is 8/10 due to the clamping pressure, but it repeats within 8/10 as long as the inserts are within the same batch number. As long as our batch numbers match, we guarantee repeatability within 8/10. So if you notice, each system's going to have coolant ports directly pinpointed to accommodate the operations we're doing. Parting and grooving operations, coolant port from the top and bottom. Part off situations, top and bottom. Turning operations, coolant port coming directly to the top, minimizing the heat going into the carbide. Same thing with turning here, turning here. All pinpointed coolant to get through those steam pockets, to break that humidity barrier and getting directly to the chip as it's curling, so we can pop those chips. Longer tool life, higher SFM, more productivity.
Thank you for taking the time to hear a little bit about the technologies that Iscar is bringing to the show this year at IMTS 2024. And please visit us at iscar.com to keep up with the latest technologies and all the information that we're putting out there about our world of cutting tools. Thank you.